A study was done on pregnant women who smoked during their pregnancies. In particular, the researchers wanted to study the effect that smoking has on pregnancy length. A sample of 114 pregnant women who were smokers participated in the study and were followed until the birth of their child. At the end of the study, the collected data were analyzed and it was found that the average pregnancy length of the 114 women was 260 days. From a large body of research, it is known that the length of human pregnancy has a standard deviation of 16 days. From this first paragraph, we see that the average pregnancy length of 114 women was 260 days. And so this is a statistic because it's come from a sample of size n equals 114. Specifically, this statistic is the mean or the average, and the notation for the mean or the average of the sample is x bar. And so we have x bar equal 260. From a large body of research, it is known that the length of human pregnancy has a standard deviation of 16 days. Since this is from a large body of research, we assume that it comes from a population. So sigma equals 16. So sigma is known. 260 days for the mean and 16 for the standard deviation. But 260 days is the mean of the sample, and 16 days is the standard deviation from the population. Based on this study, find a 95% confidence interval for mu, which is the mean pregnancy length of women who smoke during their pregnancy, and interpret your interval in context. To construct the 95% confidence interval for nouns, we're going to use the empirical rule or the 68, 95, 99.7 percentage rule. We say that 95% of the data or the observation will be within 2 standard deviation away from the mean. However, for the confidence interval, we would need 2 standard errors from the mean. The difference here is that the standard error is sigma divided by the square root of n, not just sigma. And so sigma is 16 and the square root of n, where n is 114. And that is what we need to add to or subtract to the mean. And we need to add or subtract 2 of those, 2 standard errors. And again, the reason why we use 2 is because of the 68, 95, and 99.7 percentage rule. And so the confidence interval is x bar plus or minus the critical value. Instead of 1.96, we're going to just simply use 2 as an approximation for 95% confidence interval. Sigma divided by the square root of n, where x bar is 260 plus or minus 2. Sigma is 16 divided by the square root, and n is 114. There are 2 computations here. 260 minus 2 times 16 divided by the square root of 114. Put this in a calculator, we will get 257. Another computation is a plus 260 plus 2 times 16 divided by the square root of 114, which is 263. These are the lower and the upper bound for the confidence interval. We would say that the 95% confidence interval for the mean pregnancy length is 257, 263, or 257 less than mu less than 263. We say that we are 95% confident that the true unknown mean or average pregnancy length of women who smoke during pregnancy is between 257 days and 263 days. What this means is that if we were to construct 100 confidence intervals, 95 of those confidence intervals will capture the true unknown mean.